Hello everyone. My name is 74 and I will try to do a tutorial on importing avatars to Overte. And it's the first time I'm recording a tutorial, so I'm sorry if it will be awkward or not organized well, but next one will be better. And in this tutorial, I will show you there are several methods of importing avatars to Overte. The first one is Unity importer. That's the easier method. I won't be showing that one. And another one is using Blender for that. To do this, we'll have to load a Blender file with avatar and then rename bones, rename blade shapes, work on materials, and then when it is ready, we will upload it and edit flow bones. This tutorial will be pretty much entire workflow for getting your avatar into Overte using only Blender without any other tools. And we'll be using Synth avatar for this. It was made by IronGut, and they made it open source, so it's a really awesome avatar. What else? So I think we should start. Before we start importing avatar, let's check the resources that we have about how to import avatars. Here at the main Overte website, we can go to the documentation part. And then in documentation part, we have two parts concerning avatars. So the first one is Avatar Standards Guide here. And this one refers to how we can import our avatar. So it says about proper shape of the armature. There's also standard armature provided here. It is in FBX format. So we can download it and take a look at how the bones are structured, how they are oriented. Here are the standard bone names. This will be important in a later part of the video because we need to rename the bones to the same names as shown here. And in the later part, we'll be adding flow bones. So those are like dynamic bones. We will also need to rename blend shapes so that, for example, eye blinking or face expressions will be visible. We also support a few of the custom blend shapes. Those would have to be renamed as user blend shapes. And of course, all the blend shapes can be also controlled from the script engine. So another part will be about adding flow to the avatar. We'll do that later. This one will be the same thing that, for example, in VRChat is called dynamic bones. It's very similar, and it's also used for moving parts on the avatars. So first, let's take a look at our standard armature. Here's the armature. And the most important part will be the orientation of bones and the names on the bones here. Of course, our avatar will be allowed to have less finger joints than here. So let's take a look. The first thing we will have to do is selecting the armature. And then we'll change viewport display mode. So it will be convenient here to enable access. And we can also enable names to make it easier to see which bone is exactly what. It could be convenient to change the bone type to stick because then it will be more visible and it will be easier to set them to desired angle. And now let's check our avatar, because we need to make the avatar use same bone names and same blend shape ones as Overte expects. Also, bone orientation will be very important, because otherwise bones will be twisted in weird ways. It is due to how our engine remaps standard animations to given avatar. So the first thing we should do is showing the armature. So I need to click the eye here next to the armature. And as you see, we don't see much because armature is hidden inside the model. So there is a very convenient option for this in Blender. We can just show armature in front. This is already nicer. And again, because bone orientation will be very important here, we should show bone axis right here. And maybe also, for better clarity, we should switch to wire, because right now the bone shape was covering too much of the visible area. And now let's switch to edit mode, because we will be renaming all the bones to proper names. I will also enable bone names. Oh wow, but it's a little bit too much for now. We won't be using wings in this tutorial for now, so we can hide them. I can switch to orthographic mode from perspective mode. And I can select and hide bones temporarily. So I can select them, and to hide the bones that we won't be working on for now, I can just press H, like hide. And then later I can press Alt H to show them again. Okay, so now that we have this part, we should divide the screen into parts so that it will be easier to see both the standard armature and our armature, and it will be easier to copy bone names from one to another. So let's try. Here is the standard armature. Oh, this will make it easier. So we can start renaming bones one by one. Let's start. So the main bone should be called hips. So let's rename it. And very convenient feature in Blender is that we don't actually need to select text to copy it. We just need to hover cursor over the text to copy it. To quickly move the to quickly copy the bone name, I will also need to go into edit mode here, zoom in, and here we have hips bone. So I can just copy and paste in Blender by hovering over bone name, pressing Ctrl C for copying, and then pressing Ctrl V here. And notice that I don't have to click on each one. So this will go really fast this way. Oh, the spine is overlapping. Now spine 1. Oh, sorry. Spine 1. And then spine 2. Next we have neck. And then we have a head bone. Also, capitalization is important. So, for example, head should have a capital H. Then we have a head end. And in ours, I see we have head stop end. So we should probably also rename it the same way. This avatar doesn't have eyes, but we'll have to add them. So let's try to do so right now. I will select, they need to be parented to the head, so I will select head. And then press E to extrude. Now we need to orient eyes vertically. And the eye bones are important because we have two different ways of positioning cameras on the avatar. So like positioning headset in coordinates of avatar's head. So one is based on head position, and another one is based on eyes position. So that's why it would be good to also add eyes so that both are supported. So now, after extruding, after pressing E and extruding a head bone, I will need to change relations for that bone. I need to disconnect it because, as you see, eye is parented to the head here, but it's not connected. So let's try. After disconnecting it, if I move it, I need to select on the head, and if I move it, I will have to orient it vertically. Let's see, they should only differ in Z coordinates, so I can use copy and paste here to make it identical, so only z is different, then I is perfectly vertical. And I need to position it. So for example, let's position it next to one of the eyes. Of course, positioning would be more important for avatar that has actual eyes and not just blend shapes for them. Now I need to duplicate it. So for that, I will press Shift D. Let's see if it works. No. Okay, now it works. And we can rename them to proper names. So it is left eye and the right eye. And again, capitalization is important. So this one should be left eye. And this one will be right eye. And now that they have the same naming scheme, the symmetry option of Blender should work. So right here we have apply changes to matching bone, and then if I edit one of them, another one will automatically symmetrize, and they will move together. Okay, so we have eye bones now, and the next part we need to rename our shoulders and hands, and also of course fingers. So let's start on the left one. It should be called left shoulder. The next one is left arm. Then left forearm. And then hand. And this one looks like it has two bones for the hand, which is not very good for us. So we will have to, because in our standard, it should have just a single bone for this. So action here depends on how we would like, how it is arranged. There are also intermediate bones here that shouldn't be here. So we'll need to check what kind of vertex weights are on those. So to see vertex weights, we would need to first select armature, and then while holding shift, we would need to select the mesh for which we want to check the vertex weights. Then we need to switch from object mode to weight paint. And then if we hold, I think, shift, we could select a given bone and see the weights for it. So let's check, for example, one of the index fingers. As you see, the red part is the part that is affected by a given bone. And then as colors gradually change to dark blue, it means that a given part wouldn't be affected. And here we would like to have matching avatar standard to the hands on our avatar. So then let's see here. It looks like the whole hand is assigned to just hand L bone. And then basically the bones in later part, so the bone here, and then all of those finger bones, they do basically nothing here. So first thing we need to do, first thing we need to do is disconnecting actual finger bones and thumb bones, and then connecting them straight to the head, and then we'll be able to remove rest of the bones. So now I will need to again switch into object mode, select the armature, and then switch to the edit mode. Right here, I will need to first unparent bones, exactly like we did before. So I click on connected on each one of those. And the same here. And now I need to delete unnecessary bones. So let's see what happens if I click dissolve bones. No, it doesn't work. So if I delete them, it's correct. Right now, thumb is parented directly to the hand. That's exactly like you want. We can also delete those bones. And right now, fingers are connected directly to the hand, exactly like they should be in our armature. If we take a look at our armature, also we have just left hand bone, and then we have finger bones which they are connected. Of course, here we have more fingers, but that totally doesn't matter. We can have avatar with lesser amount of fingers and finger joints, and it will still work perfectly well. Next part, since the left forearm is already renamed, the next part will be renaming, or maybe I will switch, because colors are making it difficult to read bones. I will switch to grayscale. And right now, the next part will be renaming hand bone. Next, there will be thumb. Let's try renaming it. And then we only have two thumb bones here, which is perfectly fine, it will work. And also, we need to rename finger bones in exactly the same way. Oops, it looks like I skipped something. Yes. Okay, so I skipped one. Okay. And the next one is here. And then the ring finger. And that's pretty much it for this side. Next, we'll have to do exactly the same thing on the other side of the skeleton, and I will skip that part. It turns out that for the right arm, before we started deleting bones on the left hand, we also needed to disconnect bones on the right arm or the right hand, because otherwise the thumb got deleted. So I skipped this part with naming bones on this side, but like it's very important to first disconnect bones and then only later start deleting them after both sides are disconnected. Otherwise, the mirror feature will cause that if we delete the bone on the left hand, extra bones will get deleted on the right hand because it wasn't disconnected yet. Okay, so the only part that we have left is feet. And this one will be simple because it has only three joints here. So let's take a look from the side. And as you can see, our avatar has straight legs. And this one has ones that are moved, that are rotated in different directions. So normally the animations won't be mapped correctly. In a moment I will show how to fix it. But first we should start renaming them. So let's start from the top. Oops. Okay, let's try again. And then the same with the right leg. And the right foot. Okay. And now we have just toes. And on our side, there is left toe base and left toe end. And again, end doesn't matter here. We just need to do left toe and right toe base. So let's start renaming. And also write to base. Okay, the bones are renamed now, and due to how our animation system works, bone orientations have to be the same. So if I look from the side, I need to have perspective disabled like this. So I need to have be in orthographic projection mode. As you see, the angle of the legs is different than on our avatar. And to fix this, we'll need to disconnect legs, otherwise animations won't map properly. So how do I do it? I select every bone here, and I disconnect them. Also, this one is already disconnected, and this one is connected. So I need to disconnect this one. This one is disconnected. Those are also disconnected, and we also have to disconnect finger bones. The way our animation system works, it doesn't matter where the bone ends. So the only interesting part is the beginning part. So this doesn't matter. We can use rotate tool to rotate it, and we'll need to switch to mid or maybe to active element here. Yes, this will make it easier to rotate bones. And let's rotate it like approximately vertical position. This one also needs to be rotated to vertical. And it doesn't matter that the rest of the leg is angled due to this. Due to it being vertical, the animation will map correctly. So the next part will be the foot. And here, since it's very long, it will be very important to get the correct angle. So we can take a look for the angle from our reference skeleton. And we have to try to get as well as we can similar angle here. This looks approximately the same. We'll check later during tests if it needs more adjustment or if it is correct. We can also extend the bone here. So let's try. I can press G, like grab, to move the bone, because it should be touching ground here. Otherwise, we may have problem with avatar's feet sinking into the ground. The next part are toes, and toes are already in the correct place and in the correct position because they are entirely horizontal. So let's take a look from the front. So also from the front, legs are not correctly positioned either. They need to be vertical. And they're slightly moved to the sides, which means that animation again won't be mapped correctly. So we have to move them like this, and we have to do the same here so that they will be mapped correctly, and the same with the feet. With the hands it looks correctly, and let's take a look at the spine. So with the spine again, in our avatar, the spine should be perfectly straight. And here it isn't, so again animation won't map correctly. So we need to move the bones slightly. Probably also hips would need to be a bit shorter. And let's move. Or maybe we don't even have to move the bones, but we have to disconnect them and rotate them to vertical positions. So this one is almost vertical. Spine here is vertical, but the next one is connected to it, so we need to disconnect it and also move it to vertical position. Next we have neck. Also needs to be, probably we need to disconnect head first. It's disconnected, so let's move neck to vertical position. And then head bones, which are almost vertical. They just need slight adjustment. Okay, so we have this part. So right now avatar would already work, but in game bones would be horribly twisted because we have one more bone parameter that needs to be fixed, and that one is bone rotation or bone roll. So if I select the bone, you can see the coordinate system here. And the part that interests us is which direction the z-axis is pointing to. So if I click on that small tab here, we can see a roll, and we could adjust it this way, but of course it will be very inconvenient. There are more automatic ways to do this. I can hide the toolbar again. So the more automatic way for this will be using option from armature and then bone roll. So first let's take a look at our reference armature. As you see for the legs and for the feet, Z is directed to the front. So we need to do the same here for those. So I will select first left up leg and then holding shift so that I can select more. I will select the rest of those bones like this. And now I can recalculate the bone roll. So I click bone roll, recalculate, and we can take a look at the axes here. So the way we want to direct them is negative y. So y minus here. So let's try to do this. Bone roll, recalculate roll, and the global y minus axis. Oh, exactly like that. The next part will be a toe base, so left toe base and right toe base. And as you see again, they're directed incorrectly, which means that toes would be positioned in a horribly wrong way. So to reposition them, again, we need to reset the bone roll, and we reset it to positive z direction. So bone roll, recalculate, and global z plus axis. Right now it's directed correctly. So next, this main part, like the spine. So let's see how hips are positioned. So hips are positioned to the side, so everything would be horribly twisted this way. We don't want that. So let's try. It should be positioned to the front, and the entire spine up to the head should be directed to the front, and eyes also should have Z directed to the front. So we need to correct it this way. I can select the entire spine at the same time. And we will set entire spine and the eyes to be directed to the front. So front is again y minus axis. Let's try recalculate roll and global y minus axis. Okay, this part is ready. So the next part here will be shoulders. And again, let's take a look from above. As you see, shoulders are kind of moved backwards here. And that will cause trouble because animation won't be remapped correctly to them. So I will need to move those shoulder bones here. Or I can also try disconnecting them here. This should work well. And then our animations will remap correctly. Let's try. Hand is correct because we can't have such angle. Our animation engine will just remap it here. So let's see how arms should be positioned. So in our reference armature, every bone for the arms is positioned with Z downwards on both hands. So let's do it this way. I will use a border selection to do it faster because selecting every bone would be a waste of time. Then holding shift, I will select those two bones. Again, shoulders, and then again holding shift, I will do border selection and select all the bones here to make it faster. So right now we'll need to reset bone roll so that both point downwards. Recalculate roll and Z minus. Oh, it was already done. Okay. And that's pretty much it. So at this point, Avatar would already animate correctly. So the only thing that is remaining is renaming shape keys. So I will need to switch here to object mode. I can already maximize the view because reference skeleton will not be necessary anymore. And let's see how it will work for how the shape keys look on this model. So if I switch to object mode here, I can select armature, and let's take a look. I don't need to go to edit mode. So first, let's take a look at the shape keys. Shape keys are in this tab here in properties after selecting given mesh, and every mesh can have different set of shape keys. So for example, right here, visor will have less shape keys, and the general mesh will have more of them. So as you see, there is a lot of shape keys that are designed to adjust body shape, and we can change them to our liking. And generally in Overte, we have only 9 custom blend shapes, which can control everything. And of course, we have also like non-custom ones, so ones used for face tracking and like eye blinking, speaking animations, things like that. So right here, there is way too many of them, and we'll have to optimize this and remove the bone shapes that are not required here. So blend shapes that are not required here. So to do this, as you see, I already customized the body shape. The way we do it, we can set, like you see, the different blend shapes are here, are set to different values. So for example, I could adjust body weight here. Or for example, here, and it's very important to adjust the blend shapes on all meshes, so they're on all meshes, they are set up in the same way. Otherwise, the problem is that the different part of the meshes won't match. So for example, clothes may not match after this. And at this point, I would suggest saving and making a copy of our mesh, because otherwise this operation will be destructive. We will remove the blend shapes that we don't need. But maybe before that, before copying the mesh, we'll need to modify armature a little bit more. So probably we would be interested in adding dynamic bones for the tail, so that it will move in a natural way. The way to do this, let's take a look at our avatar standards again. So we have a chapter on adding flow to avatar. So the first part is preparing avatar, and we need to rename bones in proper way, like recommended here. And then later we'll be able to adjust dynamic bone parameters in game. So let's start renaming. We have to start with the tail. And maybe it would be a good idea to create root bone for the tail. So let me try. I will try to create one. So I need to extrude hips here. So press E to extrude it. And I will need to disconnect that bone. So in bone properties, I have to first disconnect it. I will move this bone here, and I will rotate it. And now I would have to connect our tail bone to that tail base bone. So let's name this one tail base, and I will connect tail to it. We do that in relation part. Okay, so I select tail base here. It should be connected. It will be best this way. Otherwise, without tail base, it would probably also work, but our bone system still needs work, so better safe than sorry. And right here, we'll need to rename the whole bone chain. And the way we rename it, here capital letters matter. To the beginning, we need to add a flow. Then we need to add type, because we can have like multiple dynamic bone systems on a given body. Some avatars have as many as, like, for example, 16 different systems, each with several bones. So here is the type. We'll be able to adjust all the physical properties for every type separately. And then after another underscore, we have index number. So for example, 01, 02, and so on. And that it's very important to keep that conversion exactly, and avoid using extra underscores. So like the type part needs to be a single word or several words with a camel case, for example. So let's try renaming the first one. So flow underscore tail and underscore 01. And this will mean that that our system will be called tail. We can of course create, if our avatar has other systems, we could also create them. So for example, it could have like a hair flow bones or other ones. So then it would be, for example, flow hair, and we could adjust all the properties separately for every bone. So now I need to copy this and rename the next one to 02, and so on to the end of the tail. I won't do this on video because it's very boring. After renaming all of these, flow bones should already work in game later. One more thing that I noticed is that this avatar has so-called root bone here, and that is entirely not necessary. So we use just hip bone instead. So I have to press delete on the root bone, and right now hip bone shouldn't have any parent. So this is the this is the main bone to which everything is parented. So this version can already be stored, and then it would be best to make to save the version without shape keys applied. That's because the shape keys, applying shape keys will be destructive operation, and also because this avatar has a lot of different clothes available for it. So then if we would apply shape keys and we would forget which shapes keys we applied, we couldn't apply the same ones later to the clothes while exporting. And due to since Overte has a clothing system, clothes will be able to export every piece of clothes separately, and then we'll be able to mix and match them at any time using our clothing system. So the next part would be duplicating the main mesh and also visor, because it's also body part here. It looks like that's all, because dorsal fin, let's see if it has shape keys. No, dorsal fin doesn't have, and tail fluke also doesn't have shape keys, so we don't need to change anything on those. We'll just need to apply selected shape keys on main model. So we have to go through all the shape keys we have here. Of course, basis needs to be selected, and then I have to edit into go into edit mode and make those shape keys applied by default, because GLTF format doesn't allow us to say which shape keys are enabled by default, like in Blender. So then all of those would be disabled if I exported it right now, and they wouldn't work like they should. So let's start. Maybe I will for now hide the armature because it makes it look chaotic. And this is the basis shape key. And here, if I switch the shape keys, we can see different ones here. So starting from the basis, we will need to, I forgot to make a duplicate. So first, let's duplicate it. If I right click and click duplicate objects, we have a copy. I have to right click so that that copy stays in the same place. And also I will duplicate visor, and also right click so it stays in the same place. So right now I should have two visors and two main body meshes. They are hidden here over armature. So here I have body and body.001. So I will hide the copy, and I will hide the copy here also. The next part is the next part will be applying shape keys. So how to do this? I will select the body at first, go into edit mode, and now I need to select every vertex. So I could either press A on the keyboard as a shortcut, or I can go to select and click all to select everything here. After selecting, we'll need to use command finder. So by default is F3, or sometimes it's set to space. So either F3 or space. Let's see, F3, yes, it works. And we need to find a blend from shape command. So for example, if I search for shape, it will have vertex and blend from shape. And as you see, the first one, first shape key we need to blend from is neck throat fix. So let's try with this one. I'm clicking blend from shape, expanding it here, and let's see neck throat fix. It's one, and we are adding it. Okay, so we have that one. Next one will be helmet slim. Let's try again. So it remembers last comment. And again, blend is 1. Next one will be, let's see, next one will be toe no close. Like this. Okay. And so on, pretty much with every value. The one that will be a little bit different is about the ticker here. Because we don't want to have yet full value, but a bit lower one. So again, to use that part, I need to click vertex blend from shape. And then it was about the ticker, but I don't want full one. It's maybe a bit too much, but that of course depends. Let's see it. Let's set it like this. So I won't record applying all the other blend shapes because it's repetitive, but let's try. We applied all the shape keys. It looks like the model looks correct in edit mode. Of course, white basis is selected. And now if I go to object mode, it will look deformed again. So the problem is that right now shape keys are applied 2 times. So we can just either set them to 0 or delete them. And I suggest deleting all the unused shape keys from this final mesh, because otherwise, when exporting it in a GLTF format or GLB format, it will have a very large size. So frequently, models with lots of shape keys can be as big as 100 megabytes or bigger, and removing shape keys will make them a lot smaller. So we should remove the ones that we don't plan to use in game. So for example, the ones that we want to leave would be mouth open. And I don't see one for eye animation here. So maybe the eyes are just texture. So probably just mouth open and mouth open too. So here we have one of those. And here we have another one. And we can safely remove rest of them. It's best to start on the bottom because then I can just repeatedly press minus. Let's start removing the ones that are not necessary. Of course, by this time, I also applied shape keys to the visor. Need to also remove this one. And this one has pretty much only 2 shape keys here. Let's also see ones on the visor. So I also need to apply this slim shape key. I forgot, so it's not applied yet. So I have to go to edit mode, select everything again. Shortcut is A key, or I can do select all here. Both are good. And here the shape we want is helmet slim 1, weight 1. But I have to undo. I need to apply it to basis, of course. Yes, now it's correct. And again, if we go out of the edit mode, then it will be deformed. So we'll have to wipe that shape key from here, or we can set it to 0 if we want to preserve it for some reason. There is blend shape, so we'll use that one in a moment. We'll have to take a look at our avatar standards. For now, let's try deleting the unnecessary ones. This will optimize avatar nicely. And right now, let's see how blink shape works. Yes, this works perfectly. So we'll need to rename the remaining shape keys now. We have only 2 of them that we will need. So one is mouth open for talking animation, and one is for blinking here. So let's try. we'll have to take a look at the standards first to see how they're named. So as you see, like the basic blend shapes, because we have a lot more of them, we support things like eye tracking or face tracking. So there's a lot more blend shapes, and there are also user blend shapes. So you could add, you could make customizable avatars using those. And of course, all the blend shapes can be controlled from script engine. So here we'll use just the basic ones. So this is I blink left and I blink right, and also draw open. Let's try. So I will copy it from here. Again, syntax is very important. So and it's case sensitive. So we need to make sure that we type it correctly. I will paste it from there, and we'll change map open to draw open. And the next one is for blinking eyes, and we have only one blink here, so we can rename that one to I blink left. And then of course when left eye is blinking, both eyes will blink, and that will work well with our system. If you have two of them, so then of course we would have I blink left and I blink right the same way. So hopefully, right now, the only thing remaining is exporting the avatar to Overte and testing it there. And if it works well, next I will show how to export clothes and accessories, because we have lots of them here. So first, let's save. It's important because Blender crashes sometimes, and now we should export it as a GLB model. So Overte supports either FBX or GLB models. And before exporting, we should check how the materials are set up, because not everything is compatible. And for this, the shading tab in Blender will be very convenient, because then we can see preview of our materials with environmental map. And when exporting to GLB or GLTF, it's important to use like just regular PBR node that Blender supplies. So this is this principled BSDF. This is like regular physically based rendering node. And here pretty much everything is set up correctly. So if you would be importing textures from outside to Blender, it's very important, for example, for a normal map texture to be set to non-color. Otherwise, all the normals will be broken. Also, if you would have right now we don't have those, but if you would have, for example, roughness, or if you would have metallic texture, those also need to be those also need to be those also need to be set to non-color. And typically we use so-called roughness metallic texture in GLTF, and there one of the channels is roughness. I think green one is roughness and blue one is metallic, but it will be worth checking in GLTF specification. So it's a bit different from Unity, because, for example, in Unity, we have a texture called smoothness, and smoothness channel is on alpha, as far as I know, and then on red channel it has metallic, I think. Oh, and let's also check for visor. So for visor, normals are not connected. We have visor alpha channel. So let's check how alpha is set up. So in material settings, visor alpha is alpha hashed, so probably we need to switch to alpha blend. Let's see what happens. Oh no, it looks broken this way. So we'll see how alpha hashed exports. This may be a problem. Let's see how it looks with disconnected alpha. So it doesn't have ice then. Oh, it got broken. Just a moment. I'm not sure if this setup with alpha channel will be properly handled by GLTF exporter, so it would be best to simplify it, if of course possible. And the way we can simplify it here is if we zoom in, the visor consists of two parts. And the reason the alpha was used here is that one of the parts is transparent with reflection, and one part is not transparent, like below it. Both are like shiny and reflective. So we can take a look at the visor alpha texture in image viewer. So I can select it here. Let's see. So it's pretty much like two parts. One part with very low alpha, so like transparent, and one part with high alpha. So the thing we will do, we will separate it for two materials, and then we won't need that visor texture at all here. And it will be slightly less performant because we'll have two draw calls for the visor instead of one. But it will be guaranteed to work with GLB. Another thing here is that by default, Blender renders both faces on the model. So we'll need to also fix that part. And we should enable back face scaling on every avatar we export if possible, because otherwise we are losing half of performance for practically nothing for drawing invisible faces. So only reasons when we don't enable it is, for example, for transparent surfaces, which can be visible from both sides, and for so-called alpha cutout surfaces, which can also be visible from both sides. So right now we would need to enable backface scaling here, and we can also enable backface scaling on the visor. And if something glitches, that would mean that faces will be not oriented correctly. We can take a look at face orientation. Here everything looks correct, but if we would like to display it, we could switch here to face orientation, and then the parts that are in the red would mean that face orientation is incorrect. So it shows us incorrect for the visor, but I'm not sure if that is true. We'll see in a moment. We also need to enable backface scaling. And right now it shows correctly, so probably it was a glitch due to transparency. So I will disable it now. And with backface scaling, it looks even like it displays immediately. No. So probably I will need to remove. We have to take a look at it in edit mode. Also, this consists of several surfaces, and there are two shape keys. So there's basis, and there's I blink. And by moving vertices, they change the shape. And the top vertices are not visible here. The best way to do it here would be separating this into two different materials. So let's go to material tab, and as you see, right now we have single material, so that's why it needs to use alpha, and we'll separate it into two materials. So first thing we need to do is adding extra material slot. We need to do this in object mode, and first we'll also bind a visor material to it. And then I need to duplicate the visor material. So for example, let's call that visor external material, because that one will be that transparent part, and the one inside will be regular part. If I switch to edit mode, I can check which faces have which material. So if I select face selection mode here, I can click select, and right now, as we see, all the faces have the base material assigned. So of course, that's not what we want. So we will want to have just external faces with just internal faces with regular material, and then external faces with the new one. So to do this, I will click anywhere right now to deselect, and we'll need to disable X-ray mode if it is enabled. It's enabled? Not. It isn't. So we'll have to, let's see if selection works. I will switch selection to circle select. It will be more convenient, and let's see if it selects. Yes, it selects all the top ones. I can also hold shift to select more of them. And you can switch to solid shading because it will be a lot easier to see what we are doing here. There are also some small mistakes in the shading here, and those we'll fix those by splitting vertices. We could fix those by splitting vertices, but maybe not now. Oh, and now I can assign visual external material here, and that will allow us to get rid of alpha, and it will be a lot easier to export as GLTF this way. Because I'm not sure how our importer will treat external alpha texture. So the next part, I will need to switch again into viewport shading. Here it looks nice. And let's try removing alpha. So here we will have a fixed alpha value. So for example, let's see alpha. It doesn't seem to change anything yet. Because we have backface scaling enabled. So to make it work correctly, we have to see face orientation like I showed earlier. If I disable backface scaling, as you see, it's red. So let's try switching. We also need to switch from alpha hashed to alpha blend here. And right now, for the external part of the visor to show up, I will need in edit mode, we still have the faces selected. So I will need to invert them. Let's try mesh, the normals, and we can either flip or recalculate outside. Okay, so now it should be visible. If we go out of the edit mode, I can disable face orientation. Yes, if we see the reflection here, and of course, as we edit alpha right now, we can have it like full opaque, or we can have it just enough transparent to provide also nice reflection. If you want stronger reflection, it is possible to do so with a metallic parameter. But here it doesn't seem to contribute much. I think this amount of alpha should be fine. And now we can switch, we can also edit another material. Now we can get rid of alpha texture here, or we can stay, it won't be exported anyway. So now let's edit the internal material. And on the internal one, we also disconnect alpha because now it can be full opaque, like this. And we can disable alpha blending completely for the internal material. So we have to switch here to opaque. Yes, this should work. We also need to make sure that shape keys still work, because those were based on, let's see. Yes, this part is also correct. So right now, avatar, like basic avatar without clothes should be almost ready for export. I will also check if here we have backface scaling enabled or not. And here also it should be enabled. So right now, with our system of dynamic bones, there is a bug that is causing the bones to be not rendered, the dynamic bones to be not simulated properly if we don't scale armature first. I plan to be working on this somewhere later this year, but for now, we'll use a workaround for that part. To do this, I will show armature again. And I think for now, because it loses clarity due to how many bones there are, I should. So for now, I should hide the bone names because that's way too much. So in viewport display, for the armature, I can disable names. Oh, that looks a lot more clear. And now I will have to show everything. So let's see if I can select everything in Compositor. Yes, sorry, in Outliner. I can. So by pressing A, I can select every object. And now let's see if I can show them this way. Oh no, it doesn't work this way. Let's see. That doesn't seem to show. Okay, so we'll need to do this by hand. I enabled all the objects here, so all the clothes also, because we need to apply some workaround to them. And the first thing we need to do is that we need to switch to scaling or like to pivot point to use a 3D cursor as pivot point. So we're setting a pivot point to 3D cursor, and now like sometimes it happens that we move 3D cursor somewhere. So we need to make sure that it is in center of the coordinate system. So I have to right click, and here in snap options I have to click cursor to world origin like this. And the next thing I will need to do is to apply this workaround. I will need to scale everything. So I will switch here from. I will need to select everything. Right now, everything is selected, including the clouds. And now we can scale it. And to scale by given amount, we'll need to press S on keyboard, S like scale, and then enter 100. Then after entering 100, we'll need to apply this. This should be by Control A to apply transform. I think it's also in object transform, and then it should be. It's in apply here, object and apply, and then all transforms. So we need to apply all transforms to all objects. And then I need to select only armature. This is very important that I select only armature, and I scale it back. So we press, without moving to the cursor, I press S again and scale it 0.01. So it's scaled back to original size. Oh no, it looks like clothes didn't scale. So probably clothes weren't parented to the armature. We can fix that later. For now, we can just hide all the outfits, and later we'll fix that problem when we will be exporting outfits. So the next part would be optimizing Avatar more. So I'm not sure if our system will handle so many bones, and it depends if we really want to have wings or we should don't want to have them. So a good option would be removing them, or we can leave them and then they will work as accessory. Or maybe I will leave them for now because they could be useful accessory. So after this, we can try exporting, and here again some settings will be very important. So we should hide that like unmodified body with lots of shape keys, and do the same with unmodified visor. Hopefully I modified the correct visor. Yes, so I modified one that had shape keys applied, so this is correct. We should save now, and we will be able to export the model. So to export the model, I have to select only the objects I want to export. Visor, body, and armature. And let's say exporting them. We'll use GLB exporter, GLTF exporter, because that one can export everything to a single file, and it will be the modern GLTF standard. So let's export then GLTF. And let's say synth overte _1 dot GLB. It's important that we choose GLB binary here, because then all the textures, materials, everything will be included in a single file. also mesh data. If we want, we could also use the GLTF, we support it, but then we would have multiple files, and the GLTF embedded may not work with our current importer. So it's best to use either GLB or GLTF separate, but then we have multiple files. It's worth clicking remember export settings, because we've had that like every time we'll have to change settings and it's easy to forget something. And we are including only selected objects, because otherwise we would export everything that is not visible also. So all the clothes, all the like meshes that we stored earlier, all that kind of stuff. Next, let's see in the data. So very important thing is that apply modifiers is deselected, because if we select apply modifiers, all the shape keys will get automatically removed from the export. So then we wouldn't have shape keys, like for example for eye blinking or talking animation. Rest here seems correct. We can also adjust texture quality, and those textures are very simple, so I would suggest higher quality, because 75 is pretty ugly. So let's see, for example, like 96 quality. For this model, it doesn't have many textures, so it should still be very small here. Yes, and materials will be exported, images automatic, so they will be probably converted to JPEG. We are also exporting shape keys. And let's see, we don't need to export animation here, because we'll use just default animations. And let's export GLTF. So the last thing remaining that we need to do is just uploading the avatar into any kind of HTTP server. So let's try, for example, I will upload it to mine. Here is the GLB file. I have to copy it and then upload it to HTTP server. Okay, we need to check if it showed up there and the get URL. Yes, it's available. Copy link. And now we need to paste that link to Overte and see if the avatar works or is it horribly broken. Let's see. Okay, that's scared. It's loading. Oh no. So it looks like one of the heads is incorrectly parented, or it lost all the vertex weights. That's weird. Like one seems to work correctly with correct expressions on fingers and everything, and second one is broken. So we'll need to check. Default animations work very nicely generally. We just need to solve this one problem. Probably it was something with renaming bones or something like that. The reason the arm was not animating correctly, we can check also in pause mode here. So the reason for that was incorrect vertex group name. So if I select arm here, it moves with later part of the arm. The rest of the hand animates properly, so I can move it here. For pausing bones, it's very convenient to change this setting to local or gimbal. Oh, this part moves correctly, but it looks like here it's broken. So the reason for this, if we go into, we'll need to go into mesh settings and then rename groups. The problem happened during renaming the vertex weights, vertex weight groups. So if we go to mesh settings on the main mesh and then to vertex groups, we'll need to see if, for example, all the vertex groups are named correctly. So Blender automatically renames them if we rename bones, but if for a moment two bones have the same name, then it won't rename them, and that's exactly the part we need to fix. So here we have two vertex groups that both of them are called left forearm, and that is causing the trouble because, for example, obviously we should have, if I go into edit mode here or pause mode, we should have left arm and left forearm, and that's the problem. So to fix that, I will have to select mesh, and here in the mesh, I will have to change. I will have to change the name here. So we need to figure out which is which. Again, weight paint mode will be useful for this, and we can see That, of course, this one should be a left arm and not a left forearm. If I'm not wrong. Yes, right now it poses correctly. So before exporting, one more important thing is that we'll need to clear the pose again. So I go into select armature, then go into pose mode, and let's pose, clear transform, and all of them. Okay, the pose is cleared, but not for everything. I need to first select all, and then again clear transform and all. Yes, now it's correct. So the only remaining part is exporting everything again. And here our system uses quite aggressive caching. So either we'll need to have to export and then reload all the content in Overte, or we'll need to export it with a new file name. So I suggest just increasing file version number on the end of the file. So I'm selecting everything again, and then exporting GLB, GLTF. Here it's exported, so right now it should work correctly, and the only part remaining will be later setting up the flow bones. Here we have it in our file, in our local drive. We're uploading to the server, getting URL again, and now I will need to just start Overte. Let's try and test the avatar again right now with the new URL. Hopefully it works this time. It's loading, and let's see. Yes, it's much better this time. All the bones are being animated correctly. Let's see if legs are also animated. Yes, and we can also switch to selfie mode or like a second person mode to see the front. So as you see, shapeys are animating correctly, eyes are blinking. Of course, we could add more complex shapeys, but for this tutorial, this will be good enough. So the next part will be getting dynamic bones to work, because right now we have just like static tail. And the dynamic bones are kinda unfinished on our side yet. We'll need to put more work for them, but they already work, and they can have a good enough effect for now. So the first thing we need to check is again that page about adding flow to our avatar. And on this page, we have a link to Flow Up, which will allow us to adjust all the physical properties for given bones. So I will copy this link here, and I will paste it into Overte. So I need to go to edit, running scripts, and then I need to start script from disk. Sorry, from URL. I'm pasting your URL. Oh no, pasting doesn't work, sorry, on my browser. So I need to copy this way and no. One more time. Copy link, sorry. And now it should work. Yes. So now it is working. I also see there is some sort of finger or something floating here. So that's another problem, but it will be exactly the same way to correct it. It was due to renaming bones. So I will correct that part later. And for now, let's try. Yes, so one of the fingertips is missing, and it's also due to incorrectly named vertex groups. So for now, let's try to adjust the bones. So after adding that application, I have a new icon here called Flow. I need to click this one. Then the Flow application will load, and it will automatically detect all the groups of flow bones that I added to the avatar. So here it's all on the tail, but of course, like more complex avatars could have ears and could have a lot of different kinds of bones here. Let's see. So right now we should adjust it a little bit, because right now it has 0 stiffness. So if I increase stiffness, it's the shape is getting more natural. Oh, I think right now it looks reasonably well. I can also play a bit with gravity, because like the topmost parts maybe is looking, or maybe I need to increase more stiffness and less damping. Radius is for collision radius. This is for interactions. So if I set it to big, it will start colliding with itself and it will start causing trouble. Let's see right now how it works. I will switch again into third-person mode. I can also do it from either from keyboard or from menu here. Let's see how it moves. So right now it looks very reasonable, but I see there is some kind of avatar glitch there. Sometimes like some kind of ring is coming out. We'll need to fix that later. We can play a little bit more with gravity inertia, but right now it's mostly, or maybe more stiffness. So it's quite reasonable. Maybe angle of the bone in the topmost part needs correcting, but it's almost there. So the only part remaining is that we'll have to paste output from here into so-called FST file, which I will explain in a moment, and then we can save all those settings, because right now if I close the application, we lose those settings. So those will need to be saved into FST file, which I will describe in a moment. So another problem is that right now avatar is slightly floating off ground, and we need to adjust that part. So let's go to Blender, and first we need also to copy flow data, because in a moment I will explain how to do FST file. And for now, let's store it into empty Visual Studio Code document. So new text file. Oh no, it didn't copy. Okay, so we'll need to do it again later. And for now, let's fix the offset issue. So here I need to look from the side and disable perspective. Maybe in regular layout, because we already finished with materials, so let's try like this. And typically, if avatar is floating off ground, then we need to adjust it slightly. And to do this, I will need to move whole avatar downwards. And probably like moving all the clothing and everything else would be also worth it. Or we can first try with moving just armature. So I will move it downward. Let's say this much, maybe a bit deeper, or like this. And right now I need to apply, so set origin and origin to 3D cursor, so that the origin of the armature is shifted. And now let's export it again. Right now the avatar is floating, so let's try to load the newest version. I'm opening avatar menu. I will change version number here to the newest one exported. Let's see if it works better now. Oh, okay. So this part works. Now I just need to export, copy flow bone settings. So again, let's try adjusting stiffness a bit. And sadly, like our current flowbone system has a limitation that it cannot do bone chains that are curved by default, but I plan to work on it sometime soon. So soon it would be possible. Right now, bone chains are mostly straight, but this one looks reasonable. We can adjust more parts like stiffness, for example, to make it flow more. But generally it works reasonably well. After adjusting the bonds some more, I can copy the settings. So I have to go to Output tab, and I can just select those and copy them to our FST file. What is FST file? I will explain in a moment. So right now I need to just copy it into Visual Studio Code editor. Just a moment. Yes, and now we have it stored. So next part that I will explain will be how to create a FST file. The only remaining part right now is creating a FST file, like one here, and creating avatar thumbnail. I suggest like for avatar thumbnail resolution, like for example 512 by 512 by, but anything similar will work well. It shouldn't be too big to avoid loading slowly. Let's check the FST file. So I will open it in Visual Studio Code. And here you can see how it looks. So FST file has to contain avatar name. It has to contain scale. So this one is already scaled in meters, because one Blender unit should be 1 meter for us. If avatar is too big or too small, we can of course adjust scale here. And then the next part is file name. So here is file name either relative to location of FST file. For us, it's in the same place on the server, so it's relative. Or of course, we can put like full URL here for if it is located somewhere else. It can be located both FST file and this can be located on any HTTP server. Next, we have flow physics data. So we copied and pasted that area from flow app. And this should be everything for a FST file. So now the next part that will be worth trying is exporting some variables. So when we export variables, we also need to export the armature, because they have to deform in the same way the body deforms. And let's try to export, for example, tail fluke and let's see in accessories. Let's try exporting tail fluke and for example, they don't display. Maybe they're not scaled correctly. So let's see. Yes, that's probably because they were not parented to the armature earlier. So let's try parenting them. I will parent tail fluke first. I will select armature, and now let's see. In object options, we need to check relations. So let's set armature as the parent. Yes, it was correctly now. It's also scaled correctly. And we will also need to move it downwards the same way we moved the armature earlier. But that's in a moment. And also we need to do the same with dorsal fin. So we also need to parent it to armature. And it also needs to be moved lowered exactly like dorsal fin. So now let's try. We can use move tool. We can switch now from 3D cursor to a median point. And let's we apply transforms, so we can move them like this. Probably slightly bit lower. I can also use keyboard shortcuts to move them. So I can press G and then Z to move it and position it. Right now it looks very reasonable, I think. And the tail fin also merges nicely with the rest of the body. So we can export them. And for example, let's try exporting both tail fin and fluke as a single variable. I also need to select armature because otherwise they won't deform. And let's try. So I do file, export, and GLB, GLTF, and the synth Overte fluke 1. So this one we have tail fin and dorsal fin. After exporting it, we'll need to test it in Overte. The last part is testing freshly exported FST file and the wearable. So let's take a look. We again need to copy link first to FST file from our server. Later we can of course bookmark the avatar. So I'm copying FST file link, and then in avatar menu we can use it. So I'm pasting FST file link here. So as you see, automatically we got the thumbnail loaded. Avatar loads correctly, flow bones immediately work like they should. And now we should test wearables. So to do this, we have to go to wearables menu. It is this hat icon over here. Then it switches into selfie mode, and I can add custom wearable. I need to paste the link here. So let's go to our server again, copy the link, and then paste it here. Now I have to click is soft on wearable so that it will deform with armature. This is very important, for example, for things like the shirts and things like that. And if we didn't want is soft, then we could of course like add solid wearables and attach them to given bone in the avatar. So for example, we could add sword or something other that doesn't deform with avatar. So now I can click save, and let's see if it works. I will switch to third person mode again. Yes, so everything works, and that's pretty much how exporting avatar works in Overte using Blender. Of course, like I mentioned earlier, there are also different methods like Unity exporter and also Blender plugin. But this is one of the methods. If you have any questions, feel free to either join Overte and ask me there, or ask me on Overte Discord.